Hello, and welcome to another episode in Bitcoin Basics. Daniel and I today are going to be talking about hash and hash function. But before we do that, we're going to say a few words about what the purpose of this particular distinct series is and why we think it's worthwhile making it. So I'm going to pass it over to you, Daniel.
Okay, well, basically, I'm going to try to convey my idea of what concepts are of fundamental importance to understand Bitcoin, and my hope is that you will be ready to learn more, because I think that there is so much information in Bitcoin that it is easy to get lost. And you're going to be the anthropologist, and you're trying to bridge the gap between me and the rest of the world.
Yeah, I mean, I'm going to say that part of the function of this series, also for me in talking to you, is to flesh out a little bit more clearly a specific lexicography of Bitcoin. Because one of the things that does happen is that intelligent and ready to learn folks can find themselves understanding, but kind of not understanding because of a question of language. So while we looked at the various definitions of the word bits, and we thought about the definitions of entropy, we're going to do the same thing here with hash and hash function. And hopefully this series can help those people who want to deepen their understanding, get a more nuanced idea of really what are the conceptually important ideas to get across, then that will have been good work.
Yeah, so I guess my hope is like we certainly can't convey everything in this series, but my hope is you will have an idea of what to learn and what is fundamental.
Right. I think that's true. I mean, I think for anybody who wants to learn more, I think the idea is to give across the essential and most interesting and most powerful pieces, right? As well as to clarify, make sure that fundamental mistakes are not made. And then I think the other piece for my own self is to, as representative of somebody who may not ever fully read the cryptography textbook, I want to know enough to know which chapters I should go read. Um, and I think that for all the people in the space who are legitimately trying to learn more in multiple fields, that's a good place to be.
Okay, so today we're going to learn about a cryptographic hash function. And in Bitcoin, if you just hear hash function, people are probably talking about a cryptographic hash function. Um, and the difference is that you can have in computer science a hash function just means it is a way of denoting a longer message with a short uh, a a short digest, or called the hash. um, and
No,
uh,
I'm smiling, right? Because I did say, and I am looking here in the range of definitions for the word hash. You know, to begin with, we have multiple families of associations with the word hash.
Okay, well, yeah, let's talk about that first. But the point is that there are cryptographic properties that are important to what we're talking about, and which are not important if you just say hash function to a computer scientist, but they are important in Bitcoin. And if people are saying hash function, they're probably talking about a cryptographic hash function.
Okay, that's a really good point. And I also wanted to add here, before I start talking about the definitions of the words and stuff, that as somebody who has not spent, a lot or most of my time in either computer science kind of language space or cryptography language space, one of the things that does happen when one is learning about many of these elements is that hash and hash function oftentimes are almost used interchangeably. There is, understandably, when people are speaking to those that know the language, there can be a fastness and a slipperiness about it that can lead people who say understand hash in some form and function in some other form to, again, get that kind of hazy sense that you understand it well enough to repeat it, but you don't really understand it. So I wanted to just remind our viewers that, hash for many people is still a form of coarsely ground up food, often seen at breakfast tables everywhere, mostly potatoes. And we know that hash is the number sign. It's also a service stripe in a military decoration. But the one we're really interested in is a form of mathematical notation. And when we start to talk about hash function, one of the things that I know is true is that a lot of people are entirely familiar with the word function, certainly in the way in which language is used all the time and in its primary definition: kind of action or activity proper to a person, thing, or institution. Function, a purpose for which something is designed or exists, a role. Then we have social functions. Those are words which are really lodged in the forefront of most people's cognitive space. And while most people who've been to high school remember mathematical functions, if given a prod and a poke and so on, or just a prompt, to remember that thing which is the f of x use of the word function. It's important to make sure that people realize that that's what's being talked about when a hash function is being talked about. Because I think understanding, therefore, some of the cryptography is easier if you're just already aware of the fact that you're talking about mathematical functions.
Okay, yes. If that's not clear to anybody, we're talking about a math function. And in math, function means an association between two different sets, and from one to the other. And let's see, I've got my my notes here.
The function can be, when I was teaching high school math, it was always, and people were getting stuck on this, function is the operation that you do to your element input variable in order to get your output. So the function is what you do to something.
Yes, a function is an action.
Exactly.
And the idea of a hash function is we have a bunch of messages, and the messages can be big, and we want to be able to denote a particular message. And so we want to have a name for each message, and that's what the hash is. And the hash is generated from the message itself via the hash function. So I have I've written here hash function : message arrow hash. So that is math notation, and what I'm saying is that a hash function goes from the message space to the hash space, and the message space can be any length, and the hash space is fixed length because it's a name. So it's a short denoter of the message. And well, do you have any questions so far?
No questions, only a rephrasing of the hash function. You do the hash function to the message to get the hash.
And okay, so the purpose the purpose is, imagine you want to get the book 1984 out of the library, and you go to the library and ask for it. And what if the librarian gives you the Hillary Clinton edition of 1984, where the moral is that you shouldn't listen to fake news?
Right. Or you get Kafka's trial instead, right? I mean,
Well, that wouldn't be as malicious because
no.
that would still be a good alternative. But I am suggesting that there is a malicious librarian who is trying to prevent you from seeing the real message.
Hmm.
Um, and uh, uh,
But you have no way of knowing beforehand whether or not the message that you're being given is true or not without this hash, which functions as a marker or a symbol, or I'm going to use the word key, but it functions as a way of identifying an identical version of the 1984 message that went into your hash function. So
right.
it can help.
So
It
the
will
idea,
enable you to find real versions of that original message.
right. So the idea is that when George Orwell was writing 1984, he should have generated the hash and then distributed that because it's short, so it's easy to distribute, and then anybody would know that that was the correct version when they got the book out of the library. And we use this in computer science to ensure that you have downloaded the correct file. So if you are getting some software that has some very sensitive functionality to it, you want to make sure that you're using the correct one. So the publishers will also distribute the hash of each version, so that you can check. And
So
of
am
course,
I
there will
right?
also be a signature on it, so that you know that they're saying that this is the correct version. But we haven't done signatures yet.
Right. And I guess what I'm thinking is how this could be applicable to anything that is reducible to binary information in the form of a message. And if you make a marker for whatever that message is, so if you could um, turn my painting into a bits-based message and create a hash by doing a hash function to it, doing something to that, and generating a shorter hash symbol, I can then use that symbol to verify any other paintings that are exactly this information out there in the world.
Sure. Well, what you're verifying is that you have the information that you requested.
Mm-hmm.
Um, and yeah, anything in a computer is a string of ones and zeros.
Mm-hmm.
So anything can be in the message space. So you can
Mm-hmm.
denote anything with the hash function.
Mm-hmm.
So I guess now we'll talk about the properties of the cryptographic hash function.
And the hash that comes out, right? I mean,
Right,
those.
right. So get into more detail now.
Mm-hmm.
So here are the properties that a cryptographic hash function needs to satisfy. So first of all, we want to minimize the chance of a collision, and a collision means two messages which have the same hash, and it's inevitable that this possibility exists because the hash space is small. It's 160 bits or 128 bits or 256 bits. It is relatively short, whereas the message space is much bigger because a message can be megabytes long or gigabytes long or whatever. So the message space is much bigger than the hash space. So the possibility always exists of a collision, and you want to minimize that. And the way you do that is you, essentially you make the hash look like a random number. So when we generate the hash, it should it should look like a random number generator if you didn't know how the hash function worked.
Right. And so isn't that one way of assessing how good of a function you have if your function generates things that look random?
Yeah, and that's a very important criterion. And of course, it can be made mathematically more precise, but that's all we really need to say here.
Right. I think
And also, if you change any little thing in the message, then the resulting hash function should, or the resulting hash
mhm.
should be totally different, or it should be it should it should look like it's just a different random message, which means it should be about 50% the same.
Right. So the thing that I'm trying to get across here is to make sure, again, for people who are not super familiar, even with the math they learned at whatever point, right? But to make it clear that there is not a hash function. There is not the hash function. That hash function is itself something, the operation that is done is something that is done better or worse, right?
Oh, sure. Yeah. So
Right?
like Bitcoin uses SHA-256,
Right.
and there are other functions that are used in different cryptocurrencies, like script.
Mhm.
And let's see, Bitcoin also uses RipMed 160. I'm probably saying that wrong for something else, but yeah, they're different hash functions
Right.
that
So
have.
people listening to that must, as various voices talk about it, right? Because you have people who are interested only in kind of gambling trading, but they may take in information from broadcasters that does refer to some of this stuff, right? And so I think one of the things that is important to realize is that if you are trying to assess the quality of a cryptographic project, then you do need to think about how good is the function that is being applied. And so that in an
Well,
area where stuff changes or is better or is worse.
sure. Well, but that
Yeah.
that consideration really should be the domain of professional cryptographers who are designing the hash function. And then
Right, but as the outsider, if you're just armed with the knowledge that somewhere out there is a better or best function. And
sure. Well, I would say that anyone that has become a widely accepted standard is probably fine.
right, and it's fine because it's achieving these things that are here on your slide with regards to looking random and being able to generate a 50% same or 50% different hash in the event that the message is only tiny, slightly different.
Right. So yeah, so if anybody tries to change 1984 even a little bit, then they'll come up with something that looks very different
A
than the
totally
hash that you're looking for.
right, a totally different,
So
right.
so the next important criterion um, is that you can't invert the hash function. So you cannot find a message given a hash X. You can't find a message which has this hash.
Yes. And I drew a picture here at this point to kind of visualize this.
And this is a one-way function, and that's very important in cryptography. Actually, you'd better talk because I don't think that the audience can see
Oh, right. Yes,
the
I'm back
diagram.
to my picture, not just holding it passively. So the first line up here is what we've been discussing in terms of how it works. And your second point that you're making here is that you can have the hash and you can have the function, but you cannot use those to then get back to the original message.
And the reason you can't do that is that the message could be very big, and but
But also
but
you don't want your symbol, which is there to prove that you're getting a true message, to fall into likewise the wrong hands. And and I suppose because I think of cryptography in terms of secrets, if if the message itself is secret, what you're generating is a symbol in order to identify that
well,
message.
the message could be secret, but the you don't want
Legitimate or
you don't want the library to be able to design an alternate edition of 1984 that satisfies the known hash. So that's why you can't invert it, or
Gotcha.
you shouldn't be able to invert it.
Got you. So once we know what it symbolizes, it's going to symbolize that thing. You can't work backwards and change the thing that it's known to symbolize.
Right. And all of these things could happen with a very small probability, since you could just be lucky. You know, you could generate a random message which just happens to have the hash that you want. But that's kind of how cryptography usually works, is that there's a very small probability that something bad can happen, but you just make it so small that it'll never happen in the future history of the universe.
Yeah, that's the one I like, right? Imagining big numbers, or, small probabilities, whichever way you want to put it, harnessing the entire energy of the sun and lining up all human lives ever linearly, and you still won't.
Yeah. So the last criterion I put here is kind of less important, but just mentioning it just in case. So if you have the message and the hash, you can't generate a new message which also has the hash. And that's a little bit esoteric, but there are some cases where it is not possible to invert the hash function if you don't have a message, but it is possible to invert it if you have a message and the hash. So that's my list of hash function properties. And
one thing we did talk about in preparing for this that I thought was kind of interesting, and maybe you could speak really quickly as to why one would ever want to use the property of being able to take the hash of a message and then hash it again. The idea being that the hash will always fit into the range of possibilities of message to put through the hash function.
Oh, well, that's just because everything is in the message space.
Right.
Because it's just a string of bits, just like you're painting.
Why would people, I mean, yes, it's an operation that can be done. Is it the case that anybody might want to do it? Is there any benefit of hashing a hash?
Well, the hash might be part of a bigger message.
Okay.
So I was just about to talk about an application in Bitcoin. So the way the blockchain works is that every block has the hash of the previous block. So if somebody is telling you this is the latest Bitcoin block, you can say, really, is it? And if you find all of the previous blocks, you can go all the way back to the Genesis block. And
with your various hashes, which function like symbols or markers.
Right, and this is how you build the tree in a way that that everybody can agree on, and nobody can trick one another.
With what are short symbols. I was almost going to say tokens, but like,
yeah.
Exactly. Very good. And we went a bit deep on functions offline. I definitely suggest everybody revisit f of x because it's such a cool idea.
Well, let's just review. So cryptographic hash function, that means that is something that you do to a message in order to get a short denoter or indicator, and that indicator or name, which is called the hash, is going to be uniquely associated with that message with a very very, very low probability of a collision happening eventually. in the future history of the universe.
Mm-hmm. Mm-hmm.
So next, I think we're going to talk about proof of work, because proof of work is built, or I should say you can build proof of work out of a hash function, and that's what Bitcoin does. So
yeah, and I would recap also that what we've learned is that the hash function produces a hash that's functionality, okay, that's usefulness has to do with being able to verify that the next new message version, the version of the message you get, is in fact the same message that generated the hash.
okay, actually, I'd like to talk about that because it doesn't really make any sense to think of one message with different versions. So I know I gave the example of two different versions of 1984, but what we're really talking about is two different messages, and the librarian is trying to trick us by calling them both 1984.
Okay.
So it is a that is a collision right there, and the librarian can create the collision just because there isn't a hash function being used to denote the book.
Right,
So,
and that's the difference between trying to find things that are similar and setting up a system so that you can't unknowingly have a false claim pass you by.
right.
So they're subtle but different things. So the hash will allow you to make sure that you are not tricked.
Well, it'll help with certain for certain purposes, but there's lots of things in cryptography.
Yeah, no, right. As in life, there are many things you can get tricked about.
Yeah.
But very good. And I look forward to
thank you.
Bye.
Bye.